Hey, good to have you here. I'm Mani Khanuja. I'm a principal generative AI specialist solutions architect at AWS, and I've written 2 books on building these systems in production. So today we run a clinic on benchmarking. I'll show you 3 things going wrong on a real server, and you get a couple of seconds on each one to work out the cause, and then we'll go through it together. And do you need the 6 episodes before this one? Not for today, because I'll give you everything as we go, so you're fine either way. Question 1. You test your server on summarizing documents, the numbers look great, so you ship it. Then your users start using it for reasoning instead, for long step-by-step answers, and your numbers fall apart. What happened? The shape of the work changed. And by shape, I mean 2 things: how much text goes in and how much comes back out. So what does each one look like? Summarizing is a lot of text in and a little bit out, and reasoning is the other way around, a short question in and then thousands of words back out. And those 2 land on completely different parts of your server. Reading the prompt is one job, and then writing the answer out 1 word at a time is a completely different job, and they behave nothing like each other. Those 2 are called prefill and decode, and there's a whole episode on them earlier in the course. So how much does a test built on one of them tell you about the other? Almost nothing. And here's the part that catches people. The standard command everybody uses to benchmark a server has a shape baked into it already. Run it with nothing set, and it sends about 1,000 tokens in and gets 128 back. And that is the summarizing shape. So if summarizing isn't what your users do, you just tested a different product. Now there are a few more things that command does to you, and none of them is about your users. These are all your own numbers lying to you about your own server. Start with your output length. You tell it you want 128 words back. But there's a setting that lets the model stop early, and it's on by default. So you get fewer than that and a different number every single time. And what does that do to your per word timing? You end up dividing by a word count you never actually got. One setting, and your maths is honest again. Then there's the state your server is in when you start. Your server has only just started up. So the very first requests it answers are loading the model into memory and compiling code and warming everything up, and none of that ever happens again. So where does all of that end up? It ends up packed into your first few numbers. Does the command throw those away for you? It does not, because that setting is off. So the slowest requests of your whole run are sitting right at the front and dragging your average around. Then the opposite problem, and I've watched this one catch really experienced people. So you run your benchmark and you don't like the number, and you change something and run it again with the same prompts. And your server remembers them, because if a prompt starts the same way as one it has already seen, a modern server can reuse the work it did last time. So your first answer comes back much faster than it ever will for a real user. There's a whole episode on that later in the course. Fresh server or one that has already seen your prompts, either one is fine, honestly, but you do have to know which one you tested. So the traffic in your test isn't your traffic. Now it's the load you put on the server. And of everything today, this is the one I'd most like you to remember. Question 2. Your latency climbs and it never settles. Run the test for longer and the number gets worse. Run it shorter and it looks fine. What's going on? You're controlling the wrong thing here, and there are 2 ways to load a server up. You can fix the rate, so you send it 10 requests every second no matter what, or you can fix the concurrency, so you keep 50 requests in there at a time, and you only send a new one when an old one finishes. And while your server is keeping up, those 2 look identical, so you won't spot it early. But once it starts falling behind, they go completely different ways. Fix the concurrency, and there are still 50 in there, so nothing piles up, and your numbers stay honest. Fix the rate instead, and your server can't take them that fast, so a queue builds up behind it, and everything arriving late is stuck waiting behind everything that came before it. So your latency just climbs for as long as you leave the test running. And would you show anybody a result that depends on how long you ran it? I wouldn't. And the default here is the worst version of that, because the rate setting starts at infinity, and infinity means it fires every single request at once, right at the start. So that's a stress test, and it's a useful thing to run. but it's a different experiment. And here's my favorite bit. There's a setting for how grouped your requests are when they arrive, but it only does anything once you've set a rate. So at the defaults, it's not doing anything at all. Okay, so everything so far is your own test, and you can go and fix all of it this afternoon. Now, the harder half, because when somebody else publishes a number, you can't fix it. All you can do is learn to read it. Question 3, and it's the last one. You and I test the same server on the same day with the same traffic, but I use one tool and you use another. My number for the gap between words comes out higher than yours, and neither of us did a single thing wrong. Why? Because we aren't measuring the same gap. And when your server answers, the very first word is always the slowest one, because it sat in the queue and then it had to read your whole prompt before it could say anything at all. So one of those tools leaves that first word out and only measures the gaps after it. The other one keeps it in and averages it together with all the rest. So mine goes up, same server, 2 different numbers, and neither tool is wrong. And those two disagree in another way too, and you already worked this one out a minute ago. One of them keeps a steady number of requests in flight the whole way through. The other sends a batch and then waits for that whole batch to finish before it sends the next one. So what's happening to the concurrency while that batch drains away? It's dropping to nothing. That's the exact thing we just said you have to hold still, and one of those tools isn't holding it. So 2 tools can disagree. And what about 2 chips? Here's one more, and I'll just tell you this one rather than ask it. A vendor's table says their new chip is 3 times faster than the one you're running. You buy it, you deploy it, and you get nowhere near 3 times. So why not? Because that table was never a fair test, and every row on it ran a different vendor's own best software tuned their own way. So more than one thing is different between those rows, and you can't tell which difference did the work. So is that table useless to you? Not at all, because it tells you the best each one can do, and that's worth knowing. It just isn't the apples to apples comparison you'd run yourself. So before you compare any 2 rows anywhere, ask what else is different between them. And if more than one thing is, then you're looking at a demo. So don't read it as a measurement of the chip. And one last thing. Check when the number was published, because these benchmarks keep rerunning against new software, so something from a few months back might already be out of date. So what did all of those have in common? Something changed that you didn't choose. So here's your checklist, and this is the bit worth keeping. And if you were here last time, I gave you a short version of this, just enough to get your curve drawn. This is the full one. So what do you hold still on every single run? Your model and your hardware, then your server software, its version, and the settings you started it with, the shape of your traffic and how much that shape varies, and whether your cache is fresh or already warm, and which one of those gets forgotten. The server software almost every time, because defaults change between versions, and they'll change under you without telling you. Then one thing you pick on purpose and write down. Did you fix the rate or did you fix the concurrency? And write one line next to every number you keep. And that line says when it was published, when you got hold of it, and what version produced it. So screenshot that and keep it sitting next to your command. So what's the one thing to go and do this week? Don't just screenshot that list and file it away. Go and use it on something. Run your benchmark again. But warm the server up first and turn on the setting that makes it generate the full length and control the concurrency instead of the rate, and put some variation into your prompt lengths. Then put your new numbers straight next to your old ones. And how far will they move? I genuinely don't know. And that's exactly why it's worth your afternoon. But I have never once seen them land in the same place. And which set would I trust? The new ones. And that's probably what your users have been getting all along. So next time we go after the 2 walls that every server runs into, and those are compute and memory. Your test can tell you that you slowed down, but it can't tell you why. And that's what we go and fix. See you next time.